So we are looking at the revision of this paper today. Question 1. That's where I'm starting from. So the University of Zambia is carrying out the research on the career pathways of the students admitted in the School of Natural Sciences. The outcomes of the research are, of 4,000 students admitted, 2,000 want to do medicine, 900 engineering, and 600 actuarial science. In addition, 105 want medicine and engineering, 200 want actuarial science and medicine, 302 want actuarial science and engineering, and 45 would go for all. The other students made different choices of career pathways. Draw the Venn diagram to represent the information above. And then how many students did not choose medicine, engineering, and actuarial science? So we answer this question now, 1A, and then we'll come back to pick 1B. So to answer 1A, question 1A. So we have 4,000 students, and of the 4,000 for medicine, we have 2,000. Engineering, we have 900. Actuarial science, we have 600. Then medicine and engineering, we have 105. And then actuarial science and medicine, we have 200. Actuarial science and engineering, we have 302. And 45 would go for all the three. So the Venn diagram will be constructed in this manner. We have this shell here is for medicine. This shell here is for engineering. And this shell here is for actuarial science. And this is the universal, which is the University of Zambia now. So we are told that, so you always start with this number here, the 45. So 45 takes its position for all the three. Then from 45, we now go for medicine and engineering. 105. So 105, in this 105, 45 are already there. So you subtract. So you subtract 45. And we get 60. So this 60 here is for medicine and engineering. Then you go to medicine and actuarial science, 200. So from 200, you subtract 45, you get 155. So we have 155. And then actuarial science and engineering, 302 we subtract 45. So we get 7, 5, and then 2. 257 to be in this box. 257. Then now you go for individual programs. Now, those who went for medicine just, they are 2,000. But we already have in this 2,000, we already have 60, 45, and 155. So you'd add 2,000, you subtract 60, subtract 45, subtract 155. We remain with 1740. And then you go to engineering. From 900, you subtract 60, you subtract 45, you subtract 257. So you get 538. From actuarial, there's 600. So from 600, you subtract 155, you subtract 45, you subtract 257. You have 143. Then now, to get the number of the outside, from 4,000, you subtract the numbers inside here. But we know that the shell M has 2,000 in total. So you just get that 2,000 plus add, so you're saying 2,000 to be 4,000 minus 2,000 plus 538 plus 257 plus 143 to give us the complement. That will be 2,000 plus 538 plus 257 plus 143. Then this number from 4,000. So I'm getting 4,000 minus 2938, giving us 1062. So it means that one has been answered. This is a Venn diagram. Then the second part, how many students did not choose any of the three? So it will be 1062. So that if you get this one wrong, then your Venn diagram is wrong. So if any of these numbers here is not well placed, or it has a fault, then everything becomes complicated. It's even impossible to get 0. Any questions? How many marks? About 5 marks. Not that a lot. Okay. Let's go to question 2. When we go to B, solve f of x is equal to 0, given that f of x is equal to negative 3x power 3 plus 12x. Hence, sketch the function f of x, indicating all the intercepts, turning points, local maxima and minima, and intervals where the function is increasing and decreasing. This question is fully packed. So B, we want to solve f of x is equal to 0, given that f of x is equal to negative 3x power 3 plus 12x. Annie?
Sir, on the previous question, how did you find the 155?
We subtracted from 302. No. From 200 for medicine and actuarial, subtract from 200, you subtract 45.
Sir,
You know?
so when that 1062, sir, when you don't include it in the shan, writing it outside the set, all the shan is wrong.
There's simultaneous there, but it's wrong. Venn
But
diagram.
but yeah, if you don't include it in the diagram, but you find the same number of students who never attended.
You get marks for finding that number and lose marks for not indicating in the Venn diagram. So it's like the marks it was supposed to get in the Venn diagram will be compensated by getting it outside. So you still lose marks for not showing it inside. And then we gain those marks for showing it outside, but lose the marks for part 2 then. Yeah. Sequential criticism. Okay. So here's the function. We first equate it to 0, solving this one. Negative 3x to the power 3 plus 12x is equal to 0. Factor out negative 3x. You get x squared minus 4 is 0. This means x is 0, or x squared minus 4 is 0.
Sir, I can't see anything.
You must be able to see now.
Yes, sir.
So x is going to be plus or minus 2. So we have 3 x-intercepts. X is 0, x is negative 2, and x is 2. This is for part 1. For the part which says solve f of x is equal to 0. Hello?
Excuse me, sir. Yes, I was just asking if you can just reduce the speed.
All right. In writing or in speech?
I'm writing, sir.
All right. It has been reduced. Then we now look for the sketch. Now the sketch can only be complete if we find all the intercepts. So far we have found the x-intercepts. So also need the y-intercept when x is 0. So get negative 3 by 0 plus 12 by 0, giving us 0. So the y-intercept is 0, 0. Then now look for turning points. Turning points, you get the first derivative. That is negative 9x squared plus 12, and have it equated to 0. So that we get x squared is equal to 12 over 9. Twelve over 9, you square root, you get x is equal to plus or minus the root of 4 by 3 over 3. Or you can simplify it this way. 3 in 12, 4. 3 in 9, 3. So that here we get root 2 plus or minus over root 3. So that when you have this, you have now find the x coordinates for the turning points. So the turning points are going to have 2 over root 3, comma, we'll look for that, and negative 2 over root 3, comma, we'll look for that. Now looking for those, we get this and substitute in the original f. So what is f of 2 over root 3? That's going to be negative 3, 2 over root 3 to the power 3 plus 12, 2 over root 3. Meaning that we have negative 3, 2 to the power 3 is 8 over root 3 power 3 is like root 3 by root 3 by root 3. Root 3 by root 3 we get 3. 3 by root 3 we get 3 root 3. So we have 3 root 3 plus 12 by 2 we get 24 over root 3. Then this 3 and this 3 here. So we have negative 8 over root 3 plus 24 over root 3, giving us positive 16 over root 3. So this is root 3 there. So we get 16 over root 3. We also substitute. So we have obtained the corresponding for here, 16 over root 3. Then the other one, negative 2 over root 3, substituted in the original function, we get negative 2 over root 3 to the power 3 plus 12, negative 2 over root 3, giving us negative 3, negative 8 over 3 root 3 minus 24 over root 3, 3, 3. So we have positive 8 over root 3 minus 24 over root 3, giving us negative 16 over root 3. So here we have negative 16 over root 3. So now we can sketch this function. So we assemble them, yes?
Yes, sir. Is it right, sir, to assume that just take a shortcut, sir? Since we know that when we fused in 2 over root 3 in the same equation, it gave us a negative 16 over root 3. Then what if we say when we fuse in negative 2 root 3, since it's the same equation, it will give us the opposite of the positive answer?
No, the shortcuts are not shortcuts are not advised. Because that's by guessing.
Just to prove, sir. Just to prove, sir, if you are correct. Is it always correct?
It's correct by coincidence.
Okay, sir.
So now we can sketch this. So we have the turning points, -2 over root 3 and 2 over root 3. This guy against 16 over root 3. The other one against -2 over root 3. So the negatives, positives. Then the x-intercepts, we got -2, we got +2, we also got 0. So our sketch will be of this form. That is a sketch. Now, if you're asked to sketch, then it becomes easy for us to know where the function is having the find the local maxima. So local maxima. Hello.
Isn't that supposed to be -16 over root 3 there?
Yeah, you're right. -16 over root 3. Okay, then local the local minima is equal to the same -16 over root 3. And the local maxima is equal to 16 over root 3. When we say find the local maxima, local minima, it's the same thing when saying find the minimum value and the maximum value. Then, what else? The intervals where the function is increasing. Hello?
Repeat on the graph.
On the graph, you have the points obtained by solving. Now that you know the turning points, it becomes so easy for you to just come up with this curve here, making sure that it passes through the intercepts. So the key thing is, do I have the intercepts? Yes, these are the intercepts. The x-intercepts, of course. So x-intercepts, then y-intercept. This is how we used to sketch polynomials without calculus. Calculus has just added the turning points. That's all. And calculus is also adding things that you already knew to say, look, if your graph is having this behavior, if the curve is reducing in terms of its value, then you say it's decreasing there. You say it's decreasing on from -infinity all the way up to -2 over root 3. And it is also reducing from 2 over root 3 all the way up to infinity. It has this behavior here. It's the same behavior here. Where as x increases in that direction, the the functional values are becoming very, very small. Then in between here, the function values are increasing. So the function is said to be increasing, on -2/3, 2/3. It means that the question has been fully answered. That was B. So it has been fully answered. That's B. Any question?
So,
Uh-huh.
but there when you replaced in the equation, when you found x to be positive 2/3, it gave you a positive number. So you getting that, didn't that indicate that it's 16/3 is the local minimum?
The one that we talk about in that line is the second derivative. If you substitute 2/3 in the second derivative, that's the one that determines the minima and the maxima. Here we have used the first derivative in terms of the sketch to determine the local minima and max.
So, can you explain on the decreasing and the increasing?
So the decreasing and increasing from the graph, you are interested in the values of y. What is happening on the y values as the values of x vary, the interval. So as you can see that when you're coming from -infinity all the way up to -2/3, the values of y are dropping, coming down. When you reach -2/3, they start peaking. They are going up. So when they peak, we say they are increasing. When they are dropping, we say they are decreasing. And then they start falling down. So you say they are started decreasing. That's why there's a union in the decreasing.
So,
Yes.
so please just explain on the local minimum and the maximum.
So here we have used the sketch. We haven't used the second derivative to determine the local maximum and minimum. When you're using the sketch, when the quadratic curves like this, you say it has a minimum. When the quadratic curves like this, you say it has a maximum. So we are using this in our sketch where it's curving this. We are saying that is the local maximum. Local because there are other values that are higher than that. Where it does this, we are saying that is local minimum. Local minimum because we have points lower than it. Okay, so it will be cutting. We have to rejoin, so that we do C with D and keep going down. So we do that quickly.